This is Homeschool 101, a collaboration between ABS Television and the Ministry of Education. Stay attentive and attempt all activities. And now, today's lesson.
Welcome to another episode of Mathematics Homeschool 101 with me, your teacher, Mrs. Hughes Thornhill. Today, we are going to take a look at algebra. But before we get into it, let's go over the practice problems from the previous lesson. So, our two questions. Question 1. The circle below, not drawn to scale, has a diameter of 12 centimeters. The area of the circle in centimeters squared is. So we examine our circle and we examine the answers to the question, and we'll notice that pi is in each of our answers, and so we're not expected to substitute the value of pi, but to keep it as it is. Rereading the question, the circle below, not drawn to scale, has a diameter of 12 centimeters. The area of the circle in centimeters squared is. Right? So we need to remember how to find the area of a circle. So just a reminder, because we do have our formula sheet, and this is one that will be there for us. So the area of a circle is pi r squared. All right, so pi times r. Notice again, our question gave us the diameter, and so half of 12 is 6 because the radius is half of the diameter. So pi times 6 times 6. And 6 times 6 is 36, and we can already see our answer there at C. Our answer is 36 pi. Question 2. The diagram shows a sector of a circle with center O. The length of the minor arc, RS, is 5 centimeters. What is the circumference of the circle? The diameter shows a sector of a circle with center O. If the length of the minor arc, RS, is 5 centimeters, what is the circumference of the circle? So, our circle is given here. We're given a part of the circle, our sector, which is 60 degrees, and our arc RS, they gave us the length of that, which they said is 5 centimeters. So from R to S is 5 centimeters. Notice this is a part of the circumference. So in dissecting this question, the best approach would be to find out how many 60 degrees there are in the entire circle. A circle adds to 360 degrees, and so we're just going to do a division there. So we'll start with 360, and we're going to divide that by 60 degrees to find out how many 60s there are in that. Can you scroll up the I can't see question. Yeah, thank you. Good, yeah. All right. So 60 into 360, that goes 6 times. We could have, all right. So we know that there are 6 of these little pies, these sectors, all right? So what we'll do now is we'll multiply 5 by 6, and we'll get 30. So our answer there is C, which is 30 centimeters. All right, so let's talk about some patterns in algebra. Here's the first example. If a pound of potatoes is sold for $4 per pound, then can we find any value that we need, any part of this? So how much is 2 pounds? 2 pounds would cost 2 times $4, because each pound is $4. And we can continue the pattern just like that. So if we wanted to know 5 pounds, it would be 5 times $4. 10 pounds, 10 times $4. And n pounds would be n times $4. N is just a representation of how many of a pound you would like to find. So it could be 10 pounds, 50 pounds, 20 pounds, 11 pounds, whatever the value may be. So we would just substitute those n's for whichever value that we're interested in. Another example, for mobile phone plan, it costs $5 for the service charge plus 10 cents per minute. Therefore, 20 minutes would be, of course, it's $5 automatically for the service charge. And because we use 20 minutes, it's plus 20 times 10 cents per minute. Likewise, 50 minutes would be $5 plus $50 times 10 cents. 100 minutes would be $5 plus 100 times 10 cents. And of course, n minutes, how many ever minutes we'd like to calculate, $5 plus n times 10 cents. So in writing an expression in algebra, the multiplication sign is usually omitted or left out. So we're going to look at two parts of the previous examples, and the first one there, where we talked about the potatoes, we ended up with n times $4, which can also be written as $4 times n, and so it may be simply written as 4n. So we just get rid of the multiplication sign. The one about the cell phone talked about the $5 service charge plus 10 cents per minute, where we had $5 plus n times 10 cents, and simply we could just write that as 5 plus 0.10 n. What is algebra? We use algebra quite frequently in our everyday lives, and without even realizing it. We not only use algebra, we actually need algebra to solve most of our problems that involves calculations. Some examples of when we use algebra include going shopping or being able to calculate our expense. So we use algebra quite frequently in our everyday life, and without even realizing it. We not only use algebra, we actually need algebra to solve most of our problems that involves calculations. Some examples of when we use algebra include going shopping and being able to calculate our expense, knowing how much wood to buy for a particular project, and the list goes on. Simply putting it, algebra is all about finding the undefined variables into the equations and finally solving them. It is that branch of mathematics that substitutes the letters for numbers. So we're going to look at some key terms, and here you see an expression on the screen, 2x cubed plus 5. So that 2 is what we call the coefficient, and the coefficient is the number placed before the variable. And so in this example, 2 is the coefficient of x. The x is what we call the variable, and that is the letter or symbol that represents the quantity that can change. So the variable here is x. Our 3 is known as the exponent or power or even the index. And this is the number of times that the base should be multiplied by itself. The power here is 3. And then we have a plus 5, and that 5 is considered the constant. And this is a number or symbol whose quantity does not change. Okay, so again, the constant here is 5. Remember that the exponent represents the number of times the base should be multiplied by itself. So if we have 2 cubed, that just means 2 times 2 times 2. And when we multiply those, 2 times 2 is 4, times another 2 is 8. When we multiply and exponents are involved, we add the powers. So for example, if we have 3 to the 5th times 3 squared, that is simply 3 to the power of 5 plus 2, which is equal to 3 to the 7th power. Or if the base was x, in this case, we have x to the 4th times x is equal to x to the 4th plus 1, which is equal to x to the 5th. And of course, division is the opposite of multiplication. So where we added because we're multiplying, this time when we divide and exponents are involved, we subtract the powers. And so we have 2 to the 5th divided by 2 squared. It is equal to 2 to the 5th minus 2, which is equal to 2 cubed. Or x to the 4th divided by x, that's equal to x to the 4 minus 1. And 4 minus 1 is 3, so that is x to the 3rd power, or x cubed. just a little side note here. Anything raised to the power of 0 is equal to 1. For example, 2020 to the 0th power is equal to 1. Anything raised to the power of 1 is equal to that thing. So for example, 2020 raised to the first power is equal to 2020.
You're watching Homeschool 101.
So let's practice. Question 1. 7 times the product of two numbers, A and B, may be written as 7 times the product of two numbers, A and B, may be written as. So they told us our two numbers here that we're dealing with are A and B. They didn't tell us the values because that's not important at this time. And so simply writing it out, 7 times two numbers, A and B, may be written as 7AB. Question 2. When 5 is added to a number and the sum is divided by 2, the result is 7. What does this statement look like with mathematical symbols? When 5 is added to the sum, when 5 is added to a number, whatever that number is, because n is used in the answers, we'll just use n. So when 5 is added to a number, the sum is divided by 2, and the result is 7. Okay, so the answer there is C. Question 3. If x is equal to 5 and y is equal to 2, what is the value of y squared plus 4x all divided by x minus y? So this is a case of substitution, and so they told us that if x is 5 and y is 2, what is the value of this thing? So everywhere you see x, you're going to put 5, and everywhere you see y, you're going to put 2. Substitute it for 2. So we have y, that is 2 squared plus 4, and this is times, because remember in algebra when we're multiplying, the terms just come together. We don't actually use a multiplication sign. X is 5, and that is over. X is 5 minus y is 2. 2 squared, again, as you remember from one of the previous examples, is just 2 times 2, and 2 times 2 is 4. Plus 4 times 5 over 5 minus 2. 4 plus 20 over 3. How many times is 3 going to 24? And so we see our answer there. A. Okay. Question 4. If P star Q is equal to 3P minus Q squared, then 2 star 3 is equal to. This is what we call binary. And so let's just reread the question again. If P star Q is equal to 3P minus Q squared, then 2 star 3 is equal to what? So all this means is that everywhere we see P, we are going to put 2, and everywhere we see Q, we're going to make that 3. So using this part of the equation, that is 3, P is 2, minus Q is 3. 3 times 2 is 6, minus 3 times 3 is 9. 6 minus 9 is going to give us negative 3. question 5. If A is equal to 5 times P minus Q, then 10P is equal to what? If A is equal to 5 times P minus Q, then 10P is equal to what? So there's more than one way that we can approach this question. But how I'm going to do this is I'm going to just get rid of the brackets and then see how I can make that. Create a 10P and solve for 10P. Oops, sorry. Okay, so we have A is equal to 5 times P minus Q. And so if I just change that to, I expand the brackets, 5 times P is 5P. 5 times negative Q is negative 5Q, and A is still on this side. And so I can rearrange the equation here and then get my 5P to change to a 10P, or I can multiply both sides to change it to the 10P and then rearrange. So I'm going to rearrange. So because I'm solving for that part there, I'm going to take this part to the other side of the equal sign. And so to my right side, I have 5P. On my left, I have A. And when I take 5Q, a negative 5Q, across the equal sign, it becomes plus 5Q. How am I going to change this to a 10P? I would simply multiply by 2. So if I multiply by 2 here, I finally get my 10P. And if I multiply by 2 here, I will get 2 times A plus 5Q. Right, so our answer there is A. Question 6. We're going to be simplifying. So here we're given 3m squared n cubed times 4mn squared, and we want to know what that's equal to. So remember, when we multiply and exponents are involved, that we add powers, okay? Right, so I'll just rewrite the problem. 3m squared n cubed times 4mn squared. What is this equal to? Well, we have 3 times 4, so we know what 3 times 4 is. 3 times 4 is 12. We bring back our base, which is m, and we're going to add our powers. The power of m here is 2, and the power of m here is 1. And we bring back our other base, which is n. The power of n here is 3, and we're going to add it to the power of n here, which is 2. And so our answer is 12m cubed n to the 5th. So that gives us B. Question 7, we're going to simplify again. So here we have 3x plus 1, all divided by 2, plus x minus 2, all divided by 4. Now it looks a little bit complicated, but it's actually not. This is something we already know. It looks like fractions, and that's exactly what it is. So we need to remember our rules of adding fractions, and so simply what we're going to do. So when we add fractions, we know that we always have to find our LCM if the denominators are not the same. And so looking at the problem there, our denominators are 2 and 4, and so the LCM of 2 and 4 is just 4. So the LCM of 2 and 4 is 4. So now we ask ourselves, 2 into 4, or 2 times what gives us 4, and that's times 2. So we multiply the denominator by 2 and the numerator by 2. And so that gives us 2 times 3x plus 1, and we're adding it to, and we say 4 into 4 goes 1, so that means we multiplied by 1. So we just have x minus 2, and that's it. Expand the brackets, 2 times 3 is 6, 2 times 3x is 6x, plus 2 times 1 is 2, plus, and we just bring back the rest of it, x minus 2, all divided by 4, and we simplify. So you can rearrange, which I'll do. for your benefit. So we'll put our x's together. 6x plus x plus 2 minus 2. And that's still over 4. If we have 6x and we add an x, we get 7x. And if we had 2 and we take away 2, that's just 0. And so those two got rid of each other, and it's divided by 4. And so we can see our answer there at A. Question 8. The lengths of the sides of a triangle are x minus 1 centimeters, x plus 3 centimeters, and x plus 6 centimeters. The perimeter of the triangle is 26 centimeters. What is the length of the longest side? So let's note here that they gave us the perimeter, and we have to remember how perimeter is done. Perimeter, that just means we add all the sides. So if we add x minus 1 and x plus 3 and x plus 6, we're going to get 26 centimeters. That's what they told us, okay? So if this is unclear, then the best thing to do would be to rearrange the equation. So we'll just start with our x's. So we have x, and we're going to bring the plus x, our minus 1, plus 3, and plus 6 is equal to 26 centimeters. X plus x plus x, that gives us 3x. We have a negative 1 plus 3, that's 2. 2 plus 6 is 8. And now what we have is a simple equation, and so because we're going to need to solve for x, we need to get rid of anything that's attached to it, and so we're going to take our plus 8 to the other side of the equal sign. So on the left we'll have 3x, and that is equal to what's on the right side, which is 26 centimeters, and we brought over the 8, and because it was a plus 8, it now becomes minus 8. And so we have 3x is equal to 26 minus 8. That gives us 18. And so 3x is 3 times x. And so we divide by 3 because that's what's attached to the x. That's gone. So x is equal to 3 into 18 goes 6 times. So if we look at the question again, what is the length of the longest side? And the longest side for a triangle is x plus 6, and so x plus 6, that's the longest side, and if we substitute the value for x that we just got, that would mean 6 plus 6, and 6 plus 6 is 12 centimeters. So our answer there is D.
You're watching Homeschool 101.
Question 9. If 3x minus 2 divided by 5 is equal to 2, then x is equal to what? If 3x minus 2 all divided by 5 is equal to 2, then x is equal to what? So here again we can call this a simple equation, however there's a fractional part, and so we're gonna get rid of that denominator to make it look a lot nicer, okay? So you have 3x 2 all divided by 5 is equal to 2. How are we going to find what x is equal to? So we need to get rid of everything that's attached to the x. And the first thing we need to get rid of is that denominator. Here a 5 is being divided, and the opposite of division is multiplication. And remember, what you do to one side, you must always do to the other side. And so that 5 gets rid of that 5. On the left side, we end up with 3x minus 2, and that's equal to 2 times 5, which is 10. And now, this is a nice and simple equation. So we'll get rid of our minus 2, take it over to the other side. On the left, we have 3x is equal to 10. When we take the minus 2 over, it now becomes plus 2. And 10 plus 2 still solving for x, and so we have to get rid of the 3. So it's being multiplied there. Opposite of multiplication is division. And so x is equal to 3 into 12 goes 4 times. And so our answer there is A. Okay, question 10. If 2x minus 1 is less than 3x plus 6, then if 2x minus 1 is less than 3x plus 6, then x is what? Right? So this is similar to the equations, except this is called an inequality because of that sign there. And so, but it works the same way. So we will have, let me just rewrite the equation, the inequality. 2x minus 1 is less than 3x plus 6. So we're going to take our variables to one side and our constants to the other. So because my 2x is already here, I just want to keep it on my left side. So 2x, and if I take my 3x over, it is a positive 3x, and so it becomes minus 3x. And I'm going to go ahead and take my negative 1 to the other side at the same time. So rewriting my sign, I already have a positive 6. And when my negative 1 goes over, it becomes positive 1. 2x minus 3x gives us a negative x. And that is less than 6 plus 1, which is 7. But we're not looking for a negative x. We're looking for a positive x. And so remember, the x is the variable, and we know that it has a coefficient. And because there's not a visible one there, we know that the coefficient here is actually negative 1. And so I can divide both sides by a negative 1 to get rid of that negative sign. And so x, and when we divide by a negative sign, the sign also flips. And negative 1 into 7 gives us negative 7. And so our answer there is C. Okay. Question 11. The expression 3x minus 2 times x plus 1 is equal to what? So here we have two things being multiplied to each other, and what we're going to do is we're going to multiply each thing in the second bracket by each thing in the first one. So we'll start with the 3x. So 3x times x gives us 3x squared, and 3x times 1 gives us 3x. Negative 2 times x gives us negative 2x, and negative 2 times 1 gives us negative 2. And we notice that we have two x's in the middle there, and so we're just going to simplify, and we still have a 3x squared. And if we have 3x and we minus 2x, that leaves us with a positive x, and we just bring back our minus 2. So our answer is 3x squared plus x minus 2, which is B. Right? So, as usual, it's been a pleasure. And please take note of the practice problems and remember to read the questions carefully and apply the test-taking strategies. Join me for our final lesson in this series, where we'll take a look at geometry.
You've been watching Homeschool 101, a partnership between ABS Television and the Ministry of Education. Thank you for viewing this lesson. Join us again next time.